Now is another day for this exhibition. Let's go inside to find out what kind of valve we can find in this exhibition. Here is a global control valve. This control valve is going to control the flow medium CV from the flow control system. The basic principle is we are going to use the gas from here after the filter, and the gas flow to the solenoid valve. This is the solenoid valve. The only function for this solenoid valve is going to tell the user the power system still have power. And the solenoid valve will give a gas signal to the lock valve. The lock valve function is going to open the pipe, and then the gas will flow to the position. This is the position. Position will going to flow from the gas to the lock valve because this lock valve already opened by this solenoid valve, and then the gas will flow to the actuator, and then the actuator will going to move up and move down to move the trim inside the global valve, and the trim also going to give the feedback from the position. So the user can use this position to adjust the valve CV from this position and use the trim move up and move down to control the trim inside the valve. So the valve CV can be controlled by the user. Here we have a sample for this control valve trim, just like this. We are going to use the actuator to move the trim, move up and move down. So the flow medium can flow from here, and when the valve stem going up, it will going to open the valve. So the flow medium can flow, transfer the trim and move to the downside. So we can control this valve trim to control the valve CV. And also this trim going to control by the valve position. Here we have a pneumatic control gate valve. This gate valve, it has two control options. One is use a hand wheel to control the gate valve, and also we can use this very big cylinder to control the gate valve. The cylinder, the piston will control by the gas. The gas will push the piston move up and move down. It's going to control the valve stem move up and move down to control this gate valve. We can change the control option by this yellow nut. We can turn in this yellow nut, going to change the control option by the hand wheel or by the pneumatic control actuator. When we're going to use the air gas going to control the actuator, we will put the gas from here. The first one is the filter. The filter will clean the gas, and then the gas will flow to the solenoid valve, and also another way is going to flow to the lock valve. When the flow system it has gas, so the lock valve will open, and then the solenoid valve will has two-way flow outside. This is a one-way and another. Two-way will flow to the lock valve because the lock valve already opened by the gas. So we have two-way flow to the cylinder, upside and downside. So we can use the solenoid valve to change the gas, flow to the upside or flow to the downside. So we can control the piston inside the cylinder move up and move down to control the valve. And also, when the system lost the power or lost the gas, we have a lock valve. This lock valve can lock the gas inside the cylinder. So the cylinder cannot move. So the valve will still in the open position or in the closed position. Here we have very special soft seat ball valve seat. This kind of ball valve seat, it can work in 218 Celsius degree, and also can make the ball valve have zero leakage. And this ball valve seat are well designed by this manufacturer. The name is called TFM. The color is green. Here is a sample from this manufacturer. The color is a little bit like yellow. And when we're going to use this kind of soft seat ball valve, the reason why we're going to produce several grooves on the outside of the valve seat, before I already talked about. When we're going to use this kind of valve seat, if the pressure flow to the back of the valve seat, the pressure will push the valve seat against the ball. If the valve closed for a very long time, the valve seat will have permanent deformation. So that is the reason why we cut several grooves on the outside of the valve seat. So the pressure will flow to the cavity to relieve the pressure. So the valve seat will be safe. Here is a very big pneumatic actuator. We can see from here, we can see inside what does the pneumatic actuator, how the pneumatic actuator is going to work. The downside rod is going to connect with the spring and the piston. So when we're going to put the gas inside the piston we're going to push the downside rod. The downside rod we're going to push the yoke, and the yoke going to turn it, so we can open the valve. And when the cylinder lost the gas, this cylinder inside is a very big spring. The spring will push the downside rod and put the yoke back, so the valve will turn to another position. The upside rod are not going to connect with any piston or the spring. The upside rod just make the yoke firm, stable. So that rod are not going to work. Here is a very good example going to tell us how the actuator going to control the butterfly valve going to open and to close. First, we have the gas. The supply, the gas flow to the filter, and after filter, the gas will flow to the solenoid valve. And the solenoid valve will control the gas flow to two sides. And one side going to control the actuator push to one side, and another push the actuator move back. So we can turning the valve stand by the actuator and open and close the valve. In butterfly valve industry, except triple offset butterfly valve, actually we have another kind of butterfly valve. When we're going to open it, it has no rubbing. This valve called a level shut-off valve. When the valve going to open it, the valve disc will immediately left the valve seat. So the valve disc will not going to grabbing the valve seat. When we're going to open the valve has no rubbing with the valve seat and the valve disc. Here is a triple offset butterfly valve, and this one we call the level shut-off butterfly valve. Compared with the triple offset butterfly valve, this kind of valve, because the valve shafts are more complicated, so we cannot use kind of valve in very high pressure and high temperature working environment. But the advantages is this kind of valve are very easily to design and produce, so the price are much cheaper than the triple offset butterfly valve. Here we have a very big soft seat butterfly valve. The valve disc are grinding to a very shining disc. The valve seat is made by rod. This kind of valve always working in the water control industry. Here we have two very big check valves. The right one, the flow medium, we're going to flow from this side to another side. The flow medium, we're going to push the valve disc to open it. And if the flow medium flow to this side, the flow medium, we're going to push the valve disc to close the valve. So this valve is a check valve. The flow medium just can flow from one side to another. And this valve also is one check valve. The flow medium will flow to this side to push the valve disc going to open it. And if the flow medium flow to another side, it will going to push the valve disc to close the valve. So the flow medium just can flow from one side to another. It cannot flow back. It is a very big check valve. Let's look at some very small ball valve and gate valve. You may can see this kind of valve in your bathroom or in your kitchen, just like this very small ball valve. And also we have a very special one. This kind of, I think it is a global valve. The special thing is this kind of global valve, it will automatically to open or to close. It has a temperature detector. When the temperature detector detects the room temperature are higher to one level, it will going to close the valve. This kind of valve will going to control the underground heat system. Here we have a DBB ball valve. This kind of DBB function will get it from two ball valve. This valve body, it has two ball inside. The reason why we designed two balls inside the valve body because this kind of valve will work in the low temperature environment. When the sensitive flow medium trapped inside the valve body, we can turn that nut and let the flow medium bleed to outside. So it's called a double block and bleed ball valve. Here we have a very big semi-eccentric ball valve. We use a half ball design kind of ball valve, and also the valve stand are not in the center of the valve body. So we call this kind of ball valve is semi-eccentric ball valve. When the valve going to open it, the ball sealing face will immediately left the valve body seat sealing face. So the ball will not going to grab the valve seat. So this kind of ball valve, when we're going to open it, it has no rubbing. The white color just painting are not other kind of material. Here we have a very good example going to explain for us how the global control valve going to control the valve CV. First, we're going to put the pressure air inside the filter, and after filter, the gas will flow to the positioner, and the position will controlled by the user, going to control the gas flow to the actuator, and actuator will control the valve trim going up and going down. So the valve stand will going to control the valve trim to open and close, and also can travel in different positions. So the flow medium will flow inside the trim. If the trim are fully open, the valve CV will be very high. If the trim are almost closed, the valve CV will be very low. So that is the basic principle how the control valve going to control the valve CV. And also we have a feedback tell the positioner which position is about the valve trim. What an interesting machine. This machine can drilling 16 flange hole by one time. This machine can turning the flange outside the diameter by one time. It's a very interesting machine. What an interesting valve. It looks like an aircraft engine. Sorry, I don't know how to describe this valve. I don't know the function. Maybe you can tell me how this valve is going to work. Here we have two soft-seat gate valves. Two gate valves are all sealed by the soft gate and the soft seat. The difference between two gate valves is this gate valve is a non-raising stand. When we're going to close the valve or open the valve stand will not go outside of the valve body. But this gate valve, when we're going to close the valve stand will move down. But when we're going to open the valve stand will move up, will raise up. The principle are very easy to understand. This kind of non-raised gate valve. When we're going to turning the valve stand will move to inside of the valve gate. So the valve stand will hiding inside of the valve gate. So this kind of gate valve is called a non-raised valve stand gate valve. Here is another non-raised valve stand gate valve. The connections are different. It uses a flange to connect with the pipe. The basic principle is the same. The valve stand, when we're going to open the valve stand will lift the valve gate, and also the valve stand will hide inside the valve gate. The valve gate outside material is rubber. It's going to seal by the soft gate with the valve body. Here is a hydronic control valve. The function is this valve going to reduce the pressure from the upstream to the downstream. So we have two gears. This gear going to show the upstream pressure, and this gear going to show the downstream pressure. This valve will automatically to reduce the pressure. When the water flow inside the upstream and flow downstream, the pressure will be reduced. The basic principle we can see from this cut view, this sample. When the water flow to this side inside the valve body, this spring will going to push the water, and the water pressure will be reduced, and then the water going to flow to the downstream. So this kind of verb always working in the building or some kind of industry, water control industry. Here we have a very small ball valve and a very small actuator. I think it is an electric actuator. It is very cute. Here we have another very small ball valve. The actuator is a pneumatic actuator. It is very small. The ball will be very tiny inside. Here is a soft seat butterfly valve. The valve disc going to cooperate with the rubber to seal the flow medium inside. It's going to control by the pneumatic actuator open and close. Let's look at this valve seat manufacturing. What kind of material they get? They have the PFA. And also we have other kind of material like the vinyl. And the PTFE is very commonly to see in the ball valve industry. And also we have the nylon. The color is a little bit yellow. And some other kind of material. Here we have the pig ball valve seat. The size can be a very big size. Here is a pig one. And also we have the RTFE. The reason this RTFE valve seat is black color because it contains carbon fiber inside. So it can make the RTFE much harder. It can have long lifetime than the pure RTFE. Here we have a soft seat ball valve. The soft seat ball valve are well designed. First let's look at the valve seat. We can see the valve seat, the outside diameter, it has a groove. This groove is going to release the pressure from the upstream. The upstream pressure will not continue to push the valve seat against the ball. If the upstream have pressure to push the valve seat, it can relieve the pressure from the groove to the cavity. So that can protect the valve seat. And also this ball valve have well designed parking. This parking design can seal the pressure inside the valve body. When the pressure going to push the parking, because the parking, the shape are very special, so the parking will going to seal the valve stand and the valve body, so the pressure cannot release from this gap between the valve stand and the valve body. So okay, now we finish our visit from this exhibition. Thank you for watching. See you next video. Bye bye.
你好，我是机器人琪琪，有话请讲。